So welcome to the last session for today. Hopefully you still have a bit of energy left. And let's talk about DeepLens. So DeepLens is this thing here. Sorry, I don't have a very long cable for it. Right? You've seen it before. Here it is. Right? It's about right. Okay, and this was announced at reInvent, the last one, so just a few months ago. And it's a deep learning enabled camera. So what does that really mean? It runs embedded Linux. It's an Ubuntu machine, right? We'll try to SSH to it later on. And in this on this system, using an AWS service called Greengrass, which I don't know if you're really familiar with. Who's heard of Greengrass before? Yeah, okay. So it's one of the more obscure services. So we're gonna talk about Greengrass for a bit. So let's just say for the moment, it's an IoT service that lets IoT devices obviously connect to the AWS cloud and synchronize whenever they can, right? To download code in the form of Lambda functions, because the end goal is to give those devices the ability to, wow, this looks very good, thank you. Yeah, I have a bit of a cable issue again. I have a bit of a brain issue generally. But, today I focused on cable, forgetting all my cables. Very good job. So Greengrass gives devices the ability to store and process data locally, right? If you've experimented with the first IoT service that we released called AWS IoT, right? Anybody has played with this? Yeah, a few people, all right. AWS IoT lets devices publish and subscribe to message queues, but you need to be connected. So you need to be always connected if you want to send data back and forth to the cloud. Okay, with Greengrass, your devices could be disconnected. So they connect when they can, they sync, plus they have the ability to download code, so Lambda functions, that they will be able to run locally. Okay, so you write your functions in the cloud, and you push them to Greengrass-enabled devices, okay? And that means that even if a device is completely offline, it could get some data from its sensors and process that data, aggregate that data, predict on that data, and then whenever it connects to the cloud again, it could push some results, okay? So obviously, this is very important for a device like this, because we don't want to be, we don't want a model where the camera would need to be connected to the cloud to do prediction, right? That's, okay, that could work, but it would be cooler if we were able to download machine learning, or actually deep learning models to the camera, okay, and have a Lambda function run locally on the camera to process the video frames and run inference and get some results. Right? Excited? Yeah, because that's exactly what DeepLens does. Okay? So the purpose here is really what I just described. The ability to deploy a machine learning model, a deep learning model for image processing. We'll see some of the examples to the camera, and we'll see how we do that. That's the first part of the equation. And the second part of the equation is the ability to push Lambda functions to the camera automatically without having to think too hard about it, thanks to Greengrass. And that Lambda function is the one that's going to actually run the prediction. Okay? So we'll see some examples of that. All right? Yes? Is
Greengrass open source?
No. Why should it be? Yeah, well, I can think of many different things that are not open source either. It's an AWS service, right? But there is an SDK for it. Okay, so you can actually grab that on GitHub, and you can install the SDK on your device. Actually, parts of the, I mean, the cloud-based service is obviously not open source. I don't think it would make a lot of sense anyway. But the device side of Greengrass is actually on GitHub. So if you wanted to port it to your own device, you could, right? So it's doable. We have a list of supported devices, right? But if you want to port it to other devices, that works pretty well too. All right. All right. So where should we actually start? Should we try and connect the camera right away? Yeah? Let's give it a try. So once you get a camera, all right, does it say it's online, first of all? Yeah? Kind of. Hopefully it is. Okay. So you get the camera, you connect it to your Wi-Fi network. That's pretty much, what you would expect. Let me check that it is connected to my phone. Yes, it is. Okay. So let's try to SSH real quick. Check that it works before plugging it in. Okay. Where's my terminal here? Is that large enough? Yeah? Oh, yes. Okay. Okay, so now I'm connected to the cam using SSH, right? It's like I said, it's an Ubuntu system. Nothing weird about it. Okay, and Greengrass has been pre-installed. And here I'm connected to the network, so it's syncing periodically, saying if it should pull a new Lambda function or if it should do something else. Okay, but so it's really a vanilla system, vanilla Ubuntu system, and we just add a specific Ubuntu package called AWS Cam to bring all the DeepLens stuff on top of it. Okay, but you should be able to use it like a normal Unix system. Okay, so once you register this, it appears here. And now I'm going to try and actually do this. So pray to your favorite God right now. I'll pray to all of them. Yeah, you got it? Okay. Oh yeah. So I only need a keyboard, by the way. I was supposed to have a keyboard. If you have I was promised a keyboard. I can steal one from the other room, right? A USB keyboard would be great. Yeah? So what do we see here? Okay, we got the login screen, which is encouraging. All right. Okay, so, let's plug back into just checking that it works. Okay. Oh, come on. Yeah. Okay, so it's booted, and once I have a keyboard, I can actually type commands on that thing because I need to open mPlayer to see the video feed. Okay. So now obviously we want to deploy projects. Okay. So let's quickly show you the existing project. So we have a number of built-in projects that you can pick from, and these are the typical. I would say applications. Some of them, I kind of showed you this morning, detection, face detection, etc. So you can just grab any of them. Okay. Let's try face detection. Should be fun with a full room. Okay. And as you can see, what deploying a model here really means, pushing the model itself, okay? And I'll get to that, but it's an MXNet model, but it has a few specific things. So I'll get back to that, how you actually train those models. But for now, let's say it's an MXNet model. And I need a Lambda function, like I said earlier, to run inference on the frames coming from the camera, okay? And I should be able to visualize the original video feed, right, unmodified, and the one that is potentially modified by the camera, okay? So in these examples, usually, you will have bounding boxes and, what you would expect, okay? And this is the Lambda function running that stuff. Okay, so like I said, we have a model. I'll show you how to create your custom project later on. And we have a Lambda function. Okay, it's called DeepLens face detection. So if I go to my Lambda console, I should be able to see it. Cloud9. Wow, are you amazed? No. Officially, I can't make fun of it because it's so much better than the previous Lambda console. So Code9 is another AWS service that you can use standalone. It's a cloud-based IDE that some people love. I have to say I'm more of an old-fashioned guy, and I like terminals and VI and CLI, but younger developers seem to love that thing. So more power to them. And I have to say, it's so much better than the previous Lambda function. Okay, so here we go. So let's not look at everything. I just want to show you the important parts. So there is some Greengrass boilerplate in there because it is deployed by Greengrass, and this isn't a tutorial on Greengrass. What's really important is what happens here, this while loop, right? So basically, the Lambda function goes into an infinite loop, right? That's usually a bad thing, but that's what we want to do. Could I even do this? Oh, yeah. Okay, better. And this infinite loop is doing the same thing all over again, obviously. It's grabbing a frame, right, from the camera. Okay, so the last frame, the last video frame. So that's going to be a picture, a still picture. Okay. It's going to resize it because remember what we did with pre-trained networks earlier on. We have to match the input shape for the pre-trained model. Okay, so in this case, what's the input width? I'm putting my money on 224, 224. I lost. Okay, 300, 300. All right. Okay, fair enough. Okay, so you have to know that. So, by the way, when you want to use a pre-trained model, that's one of the things that the guys who train the pre-trained model have to tell you. It's like, what's the input shape? All right. So, okay, I need to resize my my picture to 300, 300, and this camera is actually 2 megapixels, so it's HD picture. So yeah, we need to resize them, right? And then we're going to run the inference on that image. Okay, so we're going to push just like it's not different from what we saw earlier on, right? We just forward that image through the model, okay? And we'll take a look at what that model is exactly in a minute. Then I grab the output, right? So it's a single-shot detector, as you can imagine, because we're going to detect faces, potentially multiple faces in the same picture. And then I'm receiving a whole bunch of information about, well, basically the output of the detection. So, where the faces are, what the bounding boxes are, et cetera, et cetera. And then I'm just iterating over those results and calling the OpenCV library again to draw a bounding box around each face. Okay? And yeah, there's some kind of label being written here. And, okay, so that should be visible on the output stream, right? The modified stream. And as you can see, this is really the Lambda function doing this work. And in addition, I can publish messages to AWS IoT, right? Because this camera is connected as an IoT device, thanks to Greengrass. So I could also push, right, some information in real time on the predictions that the Lambda function did, okay? And actually, we can connect to AWS IoT, and we can see in real time the messages that the camera sends, okay? So here, by default, it does pretty basic things. Yeah, the label doesn't seem really clever, so maybe we'll see. We'll see if we'll have time to fix this, okay? But so of course, if you want to see the stream, you have to connect the camera. But you could have the camera operating standalone and just sending IoT messages about what it sees. All right? And it does that all over again. So as you can see, the Lambda function is you could grab that one and literally cut and paste for a different model, and it would pretty much work. You would have to obviously maybe change this because the outputs of the model would be different from model to model. But this is pretty simple. There's not a lot of code to run. It's equivalent to the Python code I showed you. Forward an image, get some results, display them. All right. Not a ton of work. So let's quickly take a look. So that's for the Lambda part, right? And if we have time, we'll modify a Lambda function and try to update it, see if that works. And when it comes to the model, okay, that's the one here. Well, here it says, right? So it's a single-shot detector model based on ResNet 50. And these are, again, pre-built models, so you can just grab them from S3. But the way you would actually do this, if you wanted to try your own models, is you could use SageMaker. Okay, let's try and create a custom project just to see this. Right, and we could add one of the existing models, or I could import a model. Okay, so let's try this one. Hopefully it works. And here I should see a list of models that are available in SageMaker. Okay, so hopefully. So I could grab a model that I trained in SageMaker, just like I showed you before. Here it is. Okay, so remember those. Image classification, the decision trees, etc. Okay, so I could just grab directly a model that I trained on SageMaker and deploy that to DeepLens. Okay, awesome. Thank you very much. Sorry for being such a pain today. Thank you. All right. So grab one of those models, and that's it. Okay, so as you can see, and this is also true for additional services, SageMaker is going to be the repository for your machine learning models in AWS. That's what our customers want. They want a single place to host everything, and the ability to deploy maybe to web servers with SageMaker, maybe to DeepLens in a deep learning project. We have another service called Greengrass ML, which makes it even easier to deploy machine learning models to IoT devices. You can basically deploy them automatically, just like you would deploy the Lambda function. Today, it's a little bit more complicated than that. So SageMaker is becoming that repository where you want to have all the models and deploy them. Okay? All right, so let's go. Anything else I wanted to show you here? I think we saw everything, right? Okay, so what is the active project right now? Okay, it's object detection. All right, let's try this one first. All right, so here we go again. Bear with me. Oh, that's going to be fun. Right. Okay, so yeah. Password. All right, hopefully I remember that. It's a UK keyboard, but okay, I'll live. All right, man. Now it's all on me. It's all on me. I should have brought my own gear. Okay, let me try to get this right first try. Okay, I'll get it. No, don't worry. Oh man. All right. Can anybody help me? I'll give you the password. Any UK? I don't know if I should shift or not.
It's just the at and the double quote sign, isn't it?
No.
Is that more than that?
It might be using the French layout or the link. So I just try that first.
No. All right. Yeah. Are you a UK user? Yeah. No. I give you the password. I have weird characters and I didn't rehearse for that part. But why is that not working? That's weird. Okay. That's a problem I never had. Okay, let me try that again. Yeah, that's the right one. So come on. Yeah, probably, yeah. Come on. Okay, so username. Man, that's silly. Come on. Oh, come on. This should work. It's the correct password. All right. Can you type this? Okay. Do you have a pen? No?
Yeah.
See if you're. All right, I'm officially an idiot. Okay, but I knew that. Thank you. Man, come on. Okay, so yeah, it's. I have to say it's one of those demos where everything goes wrong. But I really insist on doing it. I don't know why. I don't think I had one fully successful run of this ever. I have no idea what I'm typing. Yeah? All right. I'll wait for the next one. Okay. This is going to be fun. All right. So now it's. So okay. Now I'm logged in, and I do need to view if I'm lucky, actually, do I have history here? I might save. Oh, yes. Here we go. Is that a 1 or is that a? Is that?
It's the French layout.
It's the French layout. Oh, that explains it. Man, come on. Okay, let me try it like this. Might be easier, all right? All right, hi.
Sit here.
No, I'm good. Okay, so let's just use the smart way of doing this. Come on. Yeah! Woo! Sorry, Twitch. Okay, now you're all deaf. Okay. Okay, so this is an object detection model. Okay, so if you're really close to the screen, it's probably going to say chair and lots of silly stuff like that. Okay, we're going to try and deploy. The face detection model. But okay, this is basically how it works. So this model is able to detect 20 types of objects, so chairs and bottles and sofas and a few more things. I think cats are in there too, but I never managed to grab my cat and get it in front of the camera, okay? So this is basically what you see, right? It's the result of the Lambda function. So we can see the bounding boxes, okay, from the Lambda function. So let's try to deploy the object detection service. Let's see if I feel lucky. Now we're going to run into different problems, of course. Okay, so let's leave it like this. So I'm back in the DeepLens console. And yeah, if it says that some of you are chairs, I apologize. Right? Let me pick the face detection project, deploy to device. Yeah, and deploy it. Okay, so fingers crossed. I think this is going to die because the Lambda is going to disappear. It's going to be replaced by something else. So let's see if we can actually get this thing to download. I'm on a pretty slow connection, but okay, it says download in progress. Please don't fail. No, it's one model only. Okay, you could run one model only because there's okay, it says download failed, of course. So I'm going to try that again because this is running. So I didn't talk about the hardware at all. So let me talk about that while I try and deploy it again. So it's an Intel. It's an Intel Atom board. Okay. So you have the Atom CPU, and it has an Intel HD graphics chip, which has a very simple GPU, right? You can't really call it a GPU, but it has a couple of hundred cores that we can leverage to actually speed up inference. But it's once it's running with one model, you can only run one model per GPU. Basically, that's what I mean, right? It would be the same for NVIDIA instances anyway, right? NVIDIA GPUs.
If I wanted to run, okay, if I can run one model at any given time,
Yep.
can I cycle through multiple models in a loop?
Yeah, you could replace them. That's what I'm trying to do. No, I can't seem to be able to download because 4G networks are slow. That's okay. We'll live with object detection for now. So you could deploy. You have APIs, and you can drive all that stuff through APIs and deploy it 10 times every day if you want. But you need a few minutes to deploy. That's what I'm saying. So you couldn't cycle in real time and do detection with multiple models. Okay, the deployment process. Okay, let me try one more time. Come on, do something. Told you this was the demo from hell. All right, let's try that again. Face detection. At least you saw the video, that's good. Okay, last try.
Maybe because you've got this model running.
No, it's strictly because to try to save on trouble, I pre-configure all of this stuff on my hotspot, on my phone hotspot. But looks like in the center of London, the best I can get is this. So probably, which operator is that? No, I don't want to give their name. Okay, but it's not great. So I've got just a too poor a network connection to, or could look even sillier and try to do it like this. Come on, download stuff, right? Living the evangelist's dream. No, it failed. All right. Okay, so we'll stick with object detection. But this is how you would do it, okay? Sorry?
Try the Wi-Fi.
No, I don't want to. No, I had enough problem with Wi-Fi today to not do this, okay? Let me show you another example. So let's make sure we have no sound here. Oh yeah, now you don't see anything. So this is from a webinar that I did. Then we're going to talk about the MXNet model because there's some devilry at work. All right. Okay, so this is from a webinar that I did a few weeks ago, and just to show you different. But I think I'm using the object detection example here too. Let's see. All right. So yeah, that's my webinar room back in Paris. Yes, we need to clean up, and yeah, it's pretty fun. But you usually don't get to see this. And so again, this is the same. This is the same camera, but in a friendlier environment with a decent network connection, and you can see again the images being predicted in real time. And yeah, so you see the chairs. That's working okay. You see the table. So it says dining table because to this model, I think all tables are dining tables, but we don't actually dine in there. I think there's a bottle. Interestingly, it does pick up stuff on the screen. So it does pick up the chairs on the TV screen, which is pretty fun. And I think at some point there's a bottle somewhere that it does pick up too.
As the Echo Dot.
Yeah, it doesn't see the echo as anything particular, right? So that's pretty stable, right? If you don't move around too much, it's actually pretty good, this SSD. So where's the bottle? I thought we had the bottle in there. Okay, yeah, so here's the bottle, and yeah, here's me, and I think it says person. So it's one of the objects that it can actually detect. So it's called an object detector, but it does pick up people too, right? All right. And so I don't really know how many frames per second that is. I never really timed it. It's probably dependent on the model. It looks like maybe, I would say maybe between 5 and 10 images per second, something like that, if you don't move around too much, because that just confuses it. But yeah, it's pretty good. And the face detection is okay. It's too bad I can't show it to you. All right. Want to try that again? Just one more switch. And then we're going to look at the model part. Okay.
To get into it, can you SSH into it instead of using...
Yes. Yes. You can SSH into it. So let me try and raise this. Okay, I'm going to mess with the cables, guys. Sorry. All right. Oh, man. Okay. Try to get more people in the... All right. So yeah, as you can see, it does pick up a lot of people. So that's the SSD to you, right? Okay, let's try the other. Oh. So could actually, yeah. All right, that's a good number of people in there, right? Pretty cool. All right, sorry, it is a tricky demo, I have to say. The other stuff was pretty smooth, but this one is a little more involved. Plus, I'm an idiot, and I forgot half my gear, so. And the tech crew did a superb job fixing this. Thank you, guys. You're awesome. Okay, so that's the basic idea. So let's look at the actual models. So that's a question we did not answer. So, whoops. So the question we did not answer is, what are these models exactly? Yeah, that's the one. So I told you this is an MXNet. This is an MXNet model, okay? And I didn't really lie. You do train this model just like you would train a normal model. So you could grab, probably a nice project to try would be to grab a pre-trained SSD, because you don't want to train an SSD from scratch. It's complicated. And fine-tune it on your own data, if you want to recognize, I don't know, different brands of cars or something. Just grab a smallish image data set, label it, and fine-tune it, and deploy it to DeepLens. I didn't bring my Raspberry Pi today. I could have done that. And if you run MXNet inference on a Raspberry Pi, remember the numbers that we got on that powerful instance earlier this morning. We were somewhere around 0.1 microsecond or something like that, right? Sub-microsecond prediction, or a few microseconds. That's good. If you try a Raspberry Pi and you just deploy MXNet to it and you use the same pre-trained model, you're going to get, in the, I would say, a few seconds per image, right? So yeah, it is much slower, okay? Because the Raspberry Pi CPU it's an ARM7 chip. It only has 4 cores. It's built for low power. It's not built for performance, okay, compared to those Intel monsters, right? The Skylakes and so on. So why am I using the Raspberry Pi reference point? Because actually this is not much more powerful than a Raspberry Pi. It is a little bit more powerful, and it has a better graphics chip. But we're in the same ballpark, okay? So we couldn't honestly say we're doing video processing if we could predict one image every 5 seconds, say, right? It's like, yeah, okay, it's video, but no. It's not even 1 FPS, so it's not working. So the problem is, how do you take those models and how do you run them more efficiently on a resource-constrained hardware like this? Okay. So the way this camera works is actually you don't run MXNet on the camera. Okay. You take an MXNet model, you convert it to using Intel tools. You convert it to a more optimized representation, and they do mostly 2 things. They optimize for the underlying hardware. Okay, so they have a highly optimized library for math operations and convolution, etc., with, I suspect, handcrafted assembly code and that kind of thing, right, to make it super, super fast for this chip. So that's you're gonna get some speed up from that. And they're also gonna fuse some layers, so they're actually gonna tweak the network in ways that are not really going to impact its accuracy, but that are going to make it a little bit faster because you have less layers to go through. Okay, it's a pretty complex process, but basically this is what they're doing, right? Compacting, so to speak, the network and using highly optimized assembly code for some math operations. Okay. And so this is an Intel suite of tools. It's called the Intel Deep Learning Inference Engine, etc. And actually, when you go and start exploring the CAM, you kind of find it, right? You don't have to look too hard. Yeah. See? Whoops, sorry about that. All right, that's what I'm talking about. Okay. So deep learning deployment toolkit. You can actually download it from the Intel website. And what it does is it has two parts. It has this model optimizer. You can see it way below. That's going to make the models more efficient for this hardware platform. And it's got the inference engine, which is pretty much a highly optimized engine to run deep learning again on this platform. Okay, so even though it's an MXNet trained model, okay, it gets converted into that Intel format that lets them run it faster on their hardware. Okay, and this is how you get better performance. You know, we're definitely not at 30 FPS, but we're not at 5 seconds per image either. Okay, so you know, we can say, hey, yeah, we are doing video processing. Low FPS, but we are doing video processing. Okay, so when DeepLens came out, it was a bit of a mystery how all this stuff worked. So I kind of reverse engineered it, posted some blog articles, etc., on actually doing all that stuff manually on the cam. No one yelled at me for doing that, so that was good. But now there's a smarter way to do this. Okay, if you're interested. Actually, there's an extra API that you can add in your Lambda function, and that's gonna optimize the model for you. Okay, so whenever the Lambda function starts, you just need to call this, and under the hood, it's gonna do those optimizations, which take a few seconds. I mean, this is not like it's not gonna take an hour. It's a few seconds, right? It's a pretty fast tool, just a few seconds to, you know, squeeze the network and optimize it. Okay, so now you don't have to mess with all those crazy operations. You can just call this from your Lambda function, and your model is going to be optimized automatically. Okay, so now the workflow for deploying to DeepLens is much simpler. Okay, you train in SageMaker, so you train one of those. You could grab one of those models here. So let's open one of my instances again. Okay, you could go and grab one of those notebooks. Okay, like the one that we trained, right? The one that we fine-tuned, the CFAR10 dataset. If you want to recognize airplanes and cats and deers, why not? Might be inconvenient to run around in the forest with one of these, but okay, dogs and cats, you can manage that well. Okay, you could take that model, save it, and yeah, I think my phone is dying now. It's okay. Just train the model, save it in SageMaker, create a custom project like I showed you in the DeepLens console, right? Pick that model hosted in S3, and literally copy and paste one of those Lambda functions. Yeah, I'm gonna go back to Wired here. Copy and paste one of those Lambda functions and just fix the small part in there that actually deals with the prediction data, right? And that's it, really. Okay, and there you have your custom project. And I think there's a DeepLens challenge. I'm not sure if it's still running. Let's try this. Yeah. So the clever ones in the room are going to say, yeah, but I will need a camera for this. And I would tend to agree. You have a question, yeah?
Is there any way you can plug a supplementary camera into the side of it so it can do 3D and depth perception?
That's a good question. So the question is, could you do 3D if you had multiple cameras? So no. The short answer is no. Today it's really, you have this one video feed that you see. Now, if you're, and you would have to be much more clever than I am, which in all likelihood is the case, you could grab those video feeds from 2 different cameras and do something clever with them if you wanted to, right? The stuff coming out from MPlayer, you know, you could just take that, process it further on a third system, and you know, and see what happens. But no, today it's really it's one single feed, and it's just 2D, right? So there's a challenge. You can make some money, right? But you need to have a camera, right? Which brings me to how do you get a camera? I have to say it's not really easy right now. You can pre-order them from Amazon.com. They should be shipping from mid-April. The problem is at the moment, this might change, but at the moment, they can only be delivered to US addresses, right? Which, I don't like, but there are good reasons for that, and I know they're working on fixing it. Okay, so it's probable that we'll be able to ship them in Europe as well, but as you can see here, for the moment you can't ship to the UK or any other location than the US actually. Okay, but if you have friends in the US and you want one of those, that's doable, right? It's pretty much what we all did with the Echoes a few years ago too. Okay. All right. What else can I tell you about this? I think that's pretty much it. So here's DeepLens. Yeah, it won't deploy, but okay, that's all right. It's my Wi-Fi connection that's the problem here. And you can grab one of those other projects and have fun. And there's the, I have to mention, yeah, we do have the hot dog, not hot dog model, which is a bit of a killer feature. If you have no idea what I'm talking about, good. This means you actually have a life and you don't waste it watching silly TV shows, okay? Dogs and cats, if you don't know what is what inside your house, we can help, right? Action recognition, this can actually be useful. You can say to your loved one, see, the camera says I'm working, right? So no, I'm not slacking, I am actually working. It's deep learning that tells it, so it has to be trusted, okay?
Would you be able to run face recognition models locally on it as opposed to
oh yeah, face recognition. Yes, there's no reason why not. So face detection is what I showed you. So we figure out there is a person in this picture. Face recognition is going one step further. Is saying, okay, you are who you are. Okay. So training a face recognition system. We have a few more minutes. I can talk about that. Training a face recognition system is actually a little bit more difficult because you need a good data set, right? I would need maybe, I don't know. If I had 100 pictures of each of you, right, we could do it. Maybe 50 would do it with less accuracy, but one picture is definitely not enough, right? We all have good days and bad days. I seem to have more bad days than anyone else. But sometimes you look in the mirror and you say, "Oh, what's that?" Right? So that's why you need a lot of pictures, okay, to be able to say, okay, you are who you are. So you need to have this. You need to have a reference picture, right? And the way you train those face recognition models is actually pretty interesting. You define a loss function. Okay, so the loss function is what you're going to optimize for. Okay, so the loss function measures the error between the prediction that the model made and truth. Okay, so for face recognition, we use a function called the triplet loss, and actually, we could think intuitively, oh, we're going to take a picture of you and a picture of someone else, and we're going to take those couples, and we're going to train on many couples, and that should be enough. And actually, it's not. The better way to do this is to use triplets. So your reference picture, and that's always going to be the same, right? So think of it as your ID card picture, a good picture that really works all the time. A second picture that would be you, but a different picture, right? So good day, bad day, terrible day, hangover, etc., right? And we call this so the first one is called the anchor picture, right? That's like the reference picture. The second one is called the positive picture. So it's still you, but a different you, right? And the third picture is called the negative picture, and it would be someone else, okay? And actually, the triplet loss function tries to minimize the sum of anchor minus positive plus anchor minus negative, okay? Because the intuition is it's not enough to know it's you. It's even better to know it's you and not someone else. Right? Sounds like a weird way of explaining it, but that's what it does.
Could be a negative picture is a deer or a cat or...
if you live in the forest, that could be nice. Yep. Why not? I mean, if your model, if you think, let's say, your pet is part of the family, and you want to recognize the pet too, why not? I don't think anybody actually tried this, but typically face recognition models are, I would say, humans. But it could be anything else, right? Actually, you could use the same system for, if you want to build a clever hot dog, not hot dog application, you could do that too. You could have the reference hot dog, many other hot dogs, and, well, there are many ways to prepare and take a picture of hot dogs, I guess, right? So you could have, 100 or 1,000 pictures of hot dogs, and you could have 1,000 pictures of other food, some of which could look like a hot dog, but, especially if you're German, but, right? But that isn't a hot dog. So yeah, the triplet loss function could work in different use cases. It doesn't have to be humans. It's actually a very precise way to learn how to detect stuff. But you need a whole lot of pictures, okay? Right, so you could do that.
Could you run this on any Ubuntu box then, or not? Do you have to have one of those?
So could you deploy it to any Ubuntu box?
On the Raspberry.
That's a good question, because the AWS CAM package is it's an Ubuntu package, so it could be deployed somewhere else. I don't know, I haven't tried it, but I suspect some of the Intel tools and some of the Greengrass stuff is going to be a little bit specific. But you can try it. I mean, just plug in a webcam. You would need to install Greengrass on that device, okay, to be able to deploy Lambdas. You would need to install the AWS CAM package, and hopefully it has what you need. And you will need to grab in your Lambda function. You would need a way of grabbing the video frame, that get last frame function. That's the one I'm worried about, because it might be looking for a specific device, a specific video device name, but maybe that can be tweaked. And then there's the inference engine. But again, okay, you could be maybe you could be running the MXNet model as is, right? If you have a powerful enough machine, that could work. So yeah, it's a cool hack project to go and try. If you get it to run, let me know. I wish I had the time to try it. All right. Oh, I should not forget the most important thing of the day. There's a happy hour in 4 minutes, right? Until 6, right? So I'm sure that kind of involves alcohol, but I wouldn't know, right? So make sure you stay around for drinks, right? And if you have more questions, I'll just hang around and answer your questions. And if you're thirsty, you can be the first in line for the happy hour. I'm sorry for the slightly rocky demo, but it's always like that. It's very difficult to do it in a controlled environment. But I still wanted to show it to you, and hopefully that was fun. And I hope you had a really good day with us. I know we did, and we'll wish you all the best. And have fun on AWS. And get in touch later on Twitter, LinkedIn, or anywhere else, on Medium, etc. If you have questions, if you need help, or if you build something cool and you want me to share it with everybody else. Okay, I'd love to do that. Thank you again. Thank you again.